Okay. Yesterday, we introduced the concept of a function. Okay. And I gave you something like this. I'll make it nice. Okay. So these are two functions that I just made up. This is read as f of x. It is not f times x. It is f of x is this. F is the name of it. This is the f function. Okay. X is the variable it uses, and this is the rule that you plug into. This is g of x. That's its name, g. Okay. That's the variable it uses, and this is the rule that you plug into. So the first thing I want to do real quick is I want you guys to find, first I want you to find f of 2, and secondly, I want you to find g of 2, and third, I want you to find f of 4 minus g of 5. So I'll pause while you guys work on that. Okay, so to find f of 2, literally, this is telling you put 2 in place of x. F of 2 means put 2 in place of x. So we're going to go, wrong pin. We're going to go 3 times 2 plus 2, because that's the rule that we use. So this is 6 plus 2, so this was 8. That's just the answer. F of 2 is worth 8, and that's all you needed to write. G of 2 is literally saying in the g function, okay, plug 2 in place of x. So we say this is 2 squared minus 2. A little arithmetic turns out to be 2. So g of 2 stayed 2 for some strange reason. Okay, before I do the other 2 over there, is that okay with everybody? That was given everybody fits yesterday. Not everybody, but enough of the class that I was kind of worried. So plugging in f of 2 or plugging in g of 2, it's just basically arithmetic, or yeah, arithmetic actually. Is that okay with everybody?
Yes.
Yes.
Better today than yesterday?
Yes,
Yes.
thank you.
Definitely.
Okay. Yeah. Okay. Now, over here, this is like 2 separate problems. F of 4 minus G of 5. This is 2 separate problems. You're going to find F of 4. You're going to find G of 5. And then later at the end, you'll subtract the 2 answers. So F of 4, we go back to the F function. We stick in 4. So we have 3 times the 4 plus 2. That's 12 plus 2. That's 14. F of 4 is worth 14. G of 5, we stick it over here. This is 5 squared minus 5. 5 squared is 25 minus 5 is 20. But the problem says take f of 4 minus g of 5. So 14 take away 20 is negative 6. That's the answer. Is that okay with everybody?
5, 5.
Yeah.
Can you just slow down just a tiny bit on these, just real quick?
Okay, yeah. I'll leave it up here. I'm not going to erase this quite yet. So do you want me to repeat something?
No, I'm following, but I'm just going slower than you and then falling behind and getting confused.
Okay. Are you caught up? Are you okay?
I'm trying to write it down right now.
All right, I'll do this. Before I move on, yesterday I was looking at the chat and I saw that Mitch had written or was writing sort of a review for stuff. Mitch, do you want to talk about that?
Yeah, I'm just starting with, there's a Quizlet. I'm doing it by chapter. I haven't really worked on it much this week, but I'll probably later this weekend for chapter 2. But it's if you guys want the link, I'll put the link in there here in a minute. I gotta transfer it over from my computer. But I'll make you guys editors if you guys would like to. Just try to keep whatever your content you're putting in the flashcards coincides with the chapter we're on, so that we can continue to study for the quizzes as they come.
Okay.
Oh, yeah, that would be nice.
That'd be awesome. Thank you.
That'd be great. If you want to not put it in the chat today, but want to take a second to get it worked out and then send me an email, I can send then your link out via email to everybody over the weekend. So you don't have to do it right now if you'd rather not. That's up to you.
It only takes a second. I got
Okay.
it.
I'll leave it up to you. Let me know, but contact me if you want me to contact the class also. I can do that. Okay, so that's basically it for functions. That's all I want to do now. When we come back next week, I'll go into more detail, but like I said yesterday, I'm afraid of overwhelming you. That's an introduction to functions. Okay, need to erase? Are we okay?
We're good.
Okay.
Okay.
Then yesterday, I also started the graph of what was called a linear equation. And it was parentheses in two variables. Okay. And we ended up right near the end of the class, there was two forms of equations that we did. Either it was like 2x plus y equals -8, where x and y were on the same side, or an alternate form, it looks like this: y equals 2/3 x minus 1, or something like that. Those are the two basic ways that we look at linear equations. Either we have them in this format, x plus y equals a number, or we have y by itself. Now, I didn't make a big deal about that. I just said, here's something. But what we really did yesterday was we said we need to find 3 solutions. Okay. And the way we do it, and actually the way mom forces you to do it, at least at the beginning, is you build a table. Okay. An X table. This is where you plug it in and you get a Y answer. And then you get, oh, good writing here, Foster, the solution, which is an ordered pair. So for example, I encouraged you, like on this problem right here, to pick 0 for x because we're lazy. It's easier to do the arithmetic. So we plug it in, we say 2 times 0 plus y equals -8. Solve that problem. So that's y equals -8. And so y is -8. So our solution was the ordered pair 0, -8. Okay, this is what we did last night. This, any number you pick for x or y, it can be any random number at all, any number you want. But because you have to do the arithmetic, you want to be lazy. You want to pick the easiest numbers possible. Okay, so we picked 0 for x because that was easy. 2 times 0 is 0. I like that. The other thing I try to encourage is don't always pick for x. Sometimes you can just plug in 0 for y. Okay, but I don't care what numbers you pick. Doesn't matter to me what numbers you pick, as long as we get 3 solutions here. Okay, this one, I would like to encourage you in a minute where I'm going to stop. Going over to this one, pick an x, plug it in. Okay, X is 0 again. Okay, that would be a good one. So you'll have Y equals 2/3 times 0 minus 1. So that's Y equals -1. And your solution here would be 0, -1 for this problem. But I want to force you to think about this problem. 1 would be a horrible number to randomly pick for X, because you'd have to go 2/3 times 1 and have fractions. 2 would be a horrible number to pick for X. I wouldn't pick a 2, because again, you're going to have fractions. What about 3? Would 3 be a good number to randomly pick for X? And the answer
Yes.
is yeah, because the 3 that you pick, okay, will cancel out with the 2/3. So you'd have 2/3 times 3 minus 1. I'm sorry. And so you're going to get some cross canceling. So you can randomly but intelligently pick numbers. So I would pick like 3 and -3, 6 and -6. Anything that would cancel with a 3, 9 and -9. Those would be my random picks. Okay, so I'm going to pause right now. I want you to get 2 more solutions for this one and 2 more, or well, actually finish this one off and get 1 more solution for this one. So let's pause. Okay, I hope you guys can read. I finished the first one off. We already did when X was 0, Y is -8. So there's a solution. When X was negative, or actually I did when Y was 0, I plugged it in and got X is -4. I didn't show my work. I just did it in my head. I'll be happy to explain that. And then I just picked an arbitrary random number for X. I said, if X is 2, or 1 rather, excuse me, if X is 1, I plugged it in and got Y is -10. So I got those. Did anybody pick any different X or different Y for the first problem?
I put
No?
-2 for X.
You -2 for X? Let me see if I can get that. That's -2. So that's -4. I had 4. -4? Is that what you got?
Yeah, that's correct.
Okay, cool. That's a good.
I picked
So-
1 for Y.
1 for Y, and you got -9/2 or -4.5?
Yes.
Yeah, okay. And as long as your math is correct, we're cool. Okay. So I want to copy these over here because I want to make some room. So this is 0, -8. This is -4, 0. This is 1, -10. And we had -2, -4. And what'd you say? -7/2 or 9/2, comma 1. Was that the last one? I think that's what you said.
Yeah, I had -4.5 or 4.
Yeah, that's fine. Yeah, that's fine. Same thing. Okay. I want to erase this table here. Is that okay with everybody? I've copied the main part over here. All right. Jumping to this one for just a second. Okay. I plugged in X was 0, and we got that one 0, -1. I showed you that 3 would be a good choice because the 3 and the 2 will eventually cross, or the 3 and the 3 will eventually cross cancel. So when I did that, I ended up with a 1. So I have a solution of 3, 1. And then I randomly picked some other numbers. I picked -3. I plugged it into my head and got -3 for Y. So that's the solution. And again, if you want to see my work plugging it in, because you tried the same thing and didn't get the right answer, I'll be happy to show you. I also tried 6 and got 3, so my solution was 6 comma 3. Did anybody pick a different X or a different Y for this equation? Pretty happy there? Okay. Then I want to erase the table except for the solution, just to make some room. Is that okay with everybody? Can I erase this table work? Okay, except for the solution.
Yes.
All right, here we go. Now, we started yesterday, we introduced something called a linear equation in 2 variables. We said it has an infinite number of solutions. We just found a few of them for each problem. But a linear equation in 2 variables has an infinite number of solutions. Okay, so we use the table to help us find some of the solutions. How do we show the infinite number of solutions? How do we show that in mathematics?
Infinity?
Well, no, you're right, it's infinity, but how do we show it? What's the
The
last
graph
thing?
with the line.
Yeah, we graph it. Okay, so what we did here is we put an XY table or an XY graph, the XY coordinate system, and we put all these points on it. And because this is called a linear equation, these ordered pairs should be in some kind of a straight line. If they're not, that's a proof that you screwed up somewhere. Because this is called a linear equation. The root word is line. Okay, so it'll make a straight line if we graph it. Same thing here. Okay, this is a linear equation. It has an infinite number of solutions. We found a few of them. Okay, but if we want to see all of them, we have to graph it. So I'm going to pause this again. I want you to graph those. So I only did the first 3 points. There's no sense doing these other ones. But roughly, you can see my scale is pretty screwed up, but more or less, it's a straight line. Okay, you connect the dots. You just don't put the dots there. Remember what we said, yes, you don't just put the big dots. You draw the line through them and beyond and put arrowheads, because it's the arrowheads that represent the infinite number of solutions. And this is where you have to kind of believe when we draw a line, we're actually technically drawing an infinite number of little dots on there. And each one of those little dots corresponds to another ordered pair. That's what we're trying to show. That's what our line is trying to show to the world. All of those infinite dots are all of the ordered pairs that we could have found for that equation. Okay, moving over to this one for a second, we have 0, -1. We have 3, 1. Okay, 3, 1. And we have -3, -3. Pretty good. So if we connect these dots again with arrows, again, the line, technically, we should be viewing it as an infinite number of dots. Nobody does that, but that's the assumption that you know that a line is made up of infinite dots, and all of those infinite little dots are all of the ordered pairs that would have been in the solution for this equation. Okay, so my question to you, all of you now is, okay, we took the equation, we used a table to get a bunch of solutions. We use those solutions to graph the line. The graph is a representation of the infinite solutions. Our table only gives us a few solutions, or our ordered pairs, rather, I should say. Same thing here. We had the equation, the rule. We got the ordered pairs. Okay, we got a few of them, but when we plot them and draw them here, it shows us the infinite solutions, all of the little invisible dots that are on that line. So let me pause. Any questions about where I got my solutions or how I graph them?
No.
I have a kind of weird question.
Okay,
Um,
can I
so
give you a
if
weird
there's
answer?
if there's an infinite amount of numbers on a line, does that mean that pi can technically be graphed on a line, or is that doesn't
Yes.
count because it's irrational?
Well, no, it's there. We could put in pi, but it's hard to calculate because it's irrational. It's hard to do arithmetic here. How would you do 2/3 times pi? You could get an approximation. Okay, so if pi was 3.14, let's look at what you're saying. Yeah, let's say we could really figure out where pi was. It was right there. Then the answer would be right there. That would be its point. Okay, but it's real hard for us to do the calculations with pi because it goes forever and ever. So it's there. We just choose to ignore it because it's a pain in the rear.
Okay, thank you.
Okay. It was not a weird question. It was a really good question. Anybody else? The bottom line I'm trying to get is when you finally get up to your homework this weekend on Mom, some of the chapter 4 homework, which I hope you're going to get to. You're now working on chapter 2 and chapter 4, remember? Okay. When you finally get up there this weekend, will you be able to take an equation? Will you be able to find 3 solutions? Will you be able to take those solutions and graph them? That's what I'm concerned with this weekend. Can you do that whether I write the equation this way or whether I write the equation this way? So do you
Think
guys
so.
think so?
Yeah.
Okay. Yeah, it looks so easy
Yeah.
when he does it in class, and then you get home alone and you go, you know. Okay. All right. Now, yesterday, I talked about the 3 views of a function. First view is its rule. The second view is its ordered pairs. And the third view is its graph. Theoretically, by the end of the semester, we should be able to take a graph, find the ordered pairs, find the rule. Or if I have the ordered pairs, can I graph it and find a rule? In other words, they're all the same thing. They're just different ways of looking at the same problem. By the end of the semester, I'll show you how. Don't panic. I'm just kind of forewarning you, giving you foreshadowing about where we're going. We should be able to change from one format to another because they're all the same. They just look different. They're different ways of representing the same information. That's what I call the 3 views of a function. The rule itself, the ordered pairs, and its graph. Those are the 3 views. Okay. Now, I'm going to pause for just a second and see if I can go to Canvas for a second. New share. Let's go to, okay, not Mom, but we'll go there. Let's go to Canvas. Boom. Okay, in Canvas, show you where I'm at. Let's go home, make sure, start fresh again. So here's Canvas home. Boom. Go to modules. Boom. Come on, go to modules. Thank you. God, stupid machine. Okay. Um, couple things I want to point out. Anne has put a couple things in her tutoring here. You might want to read that. Her Zoom link. She's put in a scheduled survey. She's put something about the stand and the resource center. So those, you might want to come back sometime this weekend and read that on your own. But down here in chapter 4, okay, we open it up and I put a video here on how to graph in MOM. It's just a little bit different, but I actually do a whole problem, show you how to graph in MOM. Okay, so if you can't figure it out, a little bit of fumbling around, a little bit of screwing around, you'll get it. It's pretty basic. I didn't read any directions. I just kind of got on MOM and kind of started screwing around and I figured it out. And then I made a video. So you should be able to figure it out also, but if you can't, go look at this video. Okay. The only problem with it that I can't, I don't think it went closed captioning, and I may have to redo it this weekend and get closed captioning, unless somebody else can figure out how to close caption it. But other than that, it's there. All right, I want to go back to our lesson. New share. Let's go back to our lesson.
Professor Foster, now I know where it is. I emailed you back, by the way, so I'm going to try and check that out tonight after the quiz.
Okay, thank you. You know what I also noticed? It wasn't your fault.
Oh,
I think I forgot to publish it.
okay.
So I keep forgetting this. It must be old age. I don't know. I keep forgetting that I can see everything.
Right. Okay.
But students can't see everything.
Right. Okay.
Okay. So I think when I sent you that message, it was because I hadn't published it yet. So
yeah, I went to the homework, mom's homework.
Oh, okay.
So I was looking, I'm like, I don't see it. I was like, oh my gosh, sorry. That's now I know where to go. So I will check that out after.
All right. Check it out and send me an email. Let me know.
Okay, I will. Thanks.
All right. All right. Okay.
And Professor, it looks like it is closed captioned on there.
Oh, it is?
Yeah.
Oh, that's good. Because okay, good.
I think you have to click it, but it works.
Well, I couldn't find, I don't want to do it right now. I'll go back and play with it, but I couldn't find a little click to say show closed captioning.
Yeah, at the bottom it says CC, and when you click it, it has closed captioning.
Really? I couldn't
Yeah.
see that. Okay, it must be I'm old and blind now too. Thank you.
It's there.
Thank you for embarrassing me. I appreciate that very much.
Anytime.
Okay. All right. Let's go back. Okay. All right. I want to do a couple more problems. Still in chapter 4, but this is the basics right now. Can you take an equation? Can you find some solutions? Now, you don't have to find a bunch of them, just 3 of them. Okay, and then can you graph them? That's all I care about right now. So I want to erase the board. Is anybody going to scream at me? No.
Yes.
Yes, you are. Thank you. Yeah.
Screaming.
Yes. Okay. That's like I taught calculus for 15 years in Poway, and I'd ask the same question. Okay, can I erase the board? You know, I'd be doing some problem that took like 5 different boards. I'm writing all over the place. I go, okay, now I need to erase the board because I need to show something else. I said, can I erase the board? My class would sit there and stare at me. I'd say, okay, I'd start to erase, and then they'd elect a different person every day to scream at me. So I wouldn't know, but somebody would scream, no, wait, you know, and then whatever. They were playing little games with me. It's okay. I got even with them though. Someday I'll tell you the trick I did to them. Ha ha. All right. So when we want to graph a linear equation, Okay. The first way is we make a table with 3 solutions. Okay, that's what we just did. Okay, but here's the second way. We're going to use something called the intercepts. And it's really just a fancy way of doing what we did up here. Okay, now we need to talk about this for just a second before I do a problem. Let's say I'm in Math 116 and I'm graphing something that looks like this. Let's do that. Okay, which you will graph in Math 116. Something like looks like that. They'll teach you how. It's not that hard. Okay, and then they'll start talking about the X-intercepts. Well, the X-intercepts are all those that fall along the X-axis. These are called the X-intercepts. Okay, the points that fall on the X-axis. So let's make up an ordered pair for this X-intercept on this one. Just for fun, just make it up. What do you think this might be?
5, 0.
No.
0, 5.
No.
-5, 0.
Thank you. -5, 0. Okay, I'm just being nitpicky. Now be careful. What do you think this one is? Like, how about 0.50? Is that okay?
Yeah.
Something like that. Don't get hung up on it. What about this one out here?
5, 0.
How much?
5, 0.
Now look at this. If this was -5, I'd say this is 4, 0. Okay, 5, 0 is fine. It doesn't matter. But what I want you to study is, what do they all have in common? These were all called the X-intercepts. What's true about every X-intercept in creation?
They're all on the X line.
And what's that mean about the Y value?
Will be
Y
0.
0.
Bingo, that's it. So when we want to find the X-intercepts, we set Y equal to 0. Okay, I'm going to show you how we do that in a minute. I'm going to work that out, but I just want you to see this. Now, this point right here, it's hard to see because I didn't draw it very well, but that's the Y-intercept. That's where the graph crosses the Y-axis. And it might be something like, can you guys see the orange? 0,1/4 or something stupid like that. Right about there, maybe. Okay. Again, what will be true about every Y-intercept in the world? What will be true about all of those Y-intercepts?
X will be 0.
Bingo, you got it. So for the Y-intercepts, did you say X is 0? Yeah, X is 0. Okay, that's really important. There's something to go on your Quizlets, your note cards. Okay, when we talk about the intercepts, and this is going to be an ongoing theme throughout the semester. Whenever we ask for the X-intercepts, that means on the X-axis, but it also means that the Y value is 0. And whenever we talk about the Y-intercept, that's on the Y-axis, and that means X is worth 0. So Mom might say something like, graph 2x minus 4y equals -8 by its intercepts. It might say that in the directions. Graph this by its intercepts. Use its intercepts. 2x minus 4y equals -8. So you start the same way. You start with the table, but we start by letting x equals 0, which is what I was trying to get you guys to do the other day. So you've got to plug it in. Okay, so you have 2 times 0 minus 4y equals -8. The 2 times 0 drops out, so -4y equals -8. So y is worth 2. And that means we have the ordered pair 0, 2. I didn't plan this out very well. Are you guys okay with my arithmetic? I divided both sides by -4. So -8 divided by -4 was 2. Now, the other intercept, we started with x is 0. We're going to start with y is 0 and work backwards. Y is 0. So plug it back in. We have 2x minus 4 times 0 equals -8. That means 2x equals -8. Divide both sides by 2, x is -4. So the ordered pair is -4, 0. Okay. So when you graph this, if the instructions say by its intercepts, you don't need 3 of them. You just need the 2 of them. So you go to 0, 2. There's the ordered pairs 0, 2. That ordered pair is that. And -4, 0. -4, 0 is there. And then you connect the dots with an arrow that goes all the way through it, a line with arrows rather, and you're done. So the intercept method is just a fast way of doing the 3 solutions. But mom will say graph by the intercept, and she is expecting that you use those 2 points when you graph it. She's expecting that you put a dot there and a dot there on your graph. So just to be careful. Okay, that's the intercept method. It's kind of like the table method, but it's easier. Okay, is that all right with everybody? Okay.
Makes sense to me.
Yeah, I want to leave that because I want to get to something else that's a little bit more complicated. This is pretty straightforward. It's kind of like a simplified version of the first one. Okay, so you guys think you could graph by intercepts, remembering that X-intercept means y is 0. So y is 0, plug it in, find x. X-intercept or Y-intercept means x is 0. You guys think you can do that or not?
Yes.
Okay, all right,
Yeah.
cool.
Yeah, I think so.
Okay, again, it's just a variation of before. So, okay, I need to erase this. I need to erase some of this.
Not yet.
Okay, I'll wait, no problem. What I want to get to is a third method for graphing linear equations. Okay, actually, it's not a method. Well, yeah, there's going to be a third and there's going to be a fourth method. Okay, we're not going to get to the trick one tonight. We'll have to wait till Tuesday for that one. Can I erase now?
Yes, please.
Okay, everybody, I can erase.
I'm good.
Okay, then we have trick equations. Okay. And those are the ones that are missing either X or Y. Somebody's missing. So I'm going to walk you through it, and you guys are going to say, whoa, do I have to do all that work? And I'm going to say, no, just don't screw up. Okay. Here we go. Example. Graph on the XY on the XY graph. Okay, whatever. Okay. X equals -3. I want to graph that. Okay. So the first thing you want to look at is you want to say, uh-oh, Y is missing. Now, this is the way I teach it. You may not like it. In the end, I don't care how you get the answer. But this is saying on your table that X is locked in at -3. Remember how on our table, X could be 1, X could be 2, X could be 0, and we had to plug it in and figure out all kinds of crud. This is saying, no, X is locked in at -3 and you can't change it. But it's saying more than that. It's saying Y is so unimportant, it can be anything you want it to be. Now, I just picked some random weird numbers, 0, -7, and 16. Okay, but that's what that's saying. When we want to graph that, it's saying that X is locked in at -3. And Y is so unimportant that it can be anything you want it to be. So it all still comes back to ordered pairs. Okay, but these are special ones where X is always -3 and Y is anything you want. Well, when we plot those, when we graph those, we get -3, 0. We get -3, -7. We get -3, 16, obviously not drawn to scale. So if we take those ordered pairs, plot them here, we can see that they're going to create a vertical line. And this is the line where X is always -3 and Y is anything along that line. We can go further. I can ask you, what's a reasonable value for that point? What do you think that might be, that ordered pair?
14.
What 14?
Oh, -3, 14.
Yeah, -3, 14. Good. That would be fine. Every X on this line is -3. That's what that's saying. So anyway, this is an example of what I call trick equations. Okay, either the X or the Y is missing. So when it's X equals -3, X is locked in at -3, Y is anything you want. You plot those ordered pairs and you're going to get a vertical line. Is that okay with everybody? All right, I need to erase that because I'm going to have you guys do another problem on your own. But questions on that one?
No.
Okay. All right, I want to erase that. So I hope you have it in your notes. And I'm going to give one for you guys to try on your own. Okay. I want you to graph this one. Um, 3y minus 5 equals 7. Graph that. I'll pause it, give you about a minute and a half, 2 minutes to do it. All right. So the first thing I would do is I would look at this and say, uh-oh, X is missing. Okay. And then I do something like damn Foster or something, because I've thrown a trick at you and I want to see, can you handle the trick? So I think the first thing I would do is add 5 to both sides. So I'd get 3y equals 12. Divide by 3 and get y is 4. X is missing. Build my XY table. Y is locked in at 4. And X can be anything in this problem. Remember, Y, it's important that Y is locked in at 4, but X is missing, so X doesn't matter. It could be 1, 3, -2. I don't care what you pick. It doesn't matter. So if we plot those points, okay, we go 1, 4. 1, 1, 2, 3, 4. Is right there. 3, 4 is right about there. -2, 4 is right about there. And we can see from those dots that it probably looks like that. So it's a horizontal line.
So if you're missing a Y or an X, likely the line is just going to be straight in whatever axis that you have.
Yes.
Okay.
Always. Okay. So think about this. On all of these other problems, when there was an X and a Y, the graph was angled in some way. Positive slope, negative slope, all kinds of things. But when it's missing an X and a Y, it's either going to be a horizontal line or a vertical line. Okay. So normal graphs with X's and Y's were slanted in some kind of weird way. Trick graphs missing an X or a Y was either going to be a horizontal or a vertical. Okay for everybody or not?
Yeah, that's perfect. Thank you.
Yeah.
Okay. What time is it? 33. Okay. I want one more topic and then we'll quit early and I'll have to get in and you can start the quiz early too. Okay. So, yeah, we got to introduce this. So one more topic here, and it's different from all of these. These are how to graph linear equations. All of this was just different ways of graphing linear equations with a table, with the intercepts, and sometimes they have tricks. When we come back on Tuesday, we'll talk about a couple other ways, but I want to get into a new topic. So erase and go forward, unless someone's going to scream at me. Nobody. Okay. Okay. So change of pace. This is chapter 4.4. Everything we've done has been chapter 4, but it's been kind of scattered all over the topics. So you should be able to whip through most of your homework. And like I said, come back on Tuesday. Monday's a holiday, right? Anne, are you still going to be there Monday? Or not? Or do you know?
The tutoring service is closed on Monday.
It's closed on Monday? Okay. All right. Well, we'll have to come up. Pay attention. We'll send out a an announcement sometime. Maybe Ann will come up with a different time and place for her tutoring thingy. Okay, but we'll figure something out. Ann will contact me, I'll contact you, or Ann will send out an announcement for extra tutoring if you guys need it. Okay, chapter 4.4, we're going to talk about a new topic called slope. Okay. Slope is a way that we measure how slanted a line is. Slant of a line. Whoops. Okay. And when we talk about slope, okay, we in math use a lowercase m, which I can't write. It looks more like a caterpillar than it looks like an M. I think science uses the letter K for constant. Okay, they're wrong, we're right. Some people talk about the change in Y divided by the change in X, and other people call the same thing delta Y, delta X. Now, we got into science. Slope is how slanted a line is. It's a way that we measure the slant of a line. And when I do a problem here, I'll make that clear. In math, we use the symbol, the lowercase letter m, to represent the slope. But it measures how does the y change compared to how does the x change. And in science, they use the Greek letter triangle, which is read delta. You don't need to know this. That's not going to be on the test, but you may run into it. This is called delta, D-E-L-T-A. It's the Greek letter, and in science, it means change. The change in y, how did the y values change compared to the x values? Okay. And there's a formula that you do need to memorize. Okay. The formula for slope is m equals, now don't get panicky. This is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. That's the formula you need to memorize. And I'm going to show you what it means and how we do it in a second. Now, technically, this is called sub 2. Okay, and I think I'm the only person in the world who calls it sub 2. It's called a subscripted variable. It's the little 2z is down low. Like when you have an exponent, when you write x squared, that's called a superscripted variable. The little power is above. If you put something down there, this would be a subscripted, so x sub 3 squared. But it's called a subscript. I'm the only person in the world who makes a big deal about this. Okay, most of the other instructors just call that y2 minus y1. I hate that, but that's my problem. Okay, so let me do a problem and I'll show you what it means. Okay, example. Find the slope of the line that contains, I can't spell it right, contains the points 3, -4 and 5, 7. Find the slope of the line that contains these points. Okay. I'm going to draw it. You do not have to. You have this formula, you're cool, okay? But I'm going to show you. We go to 3, -4. 1, 2, 3, -4. Somewhere like that. 5, 7 is like right there. So here's the line that I'm talking about. Okay. And I want to know what's the slope of that line. How is it slanted? How is it sloped? I want to know that. So according to the formula, we take, when we say y sub 2, that means literally the second y value minus the first y value. That's what it means. Second y value minus first y value. So that would be 7 minus a -4. The second y value, that's the y value on the second point, minus the first y value. That's the y value on the first point. So 7 minus a -4. Notice the formula has its own minus. Over, this says x sub 2, this says the second x value, 5, minus the first x value, 3. Okay? Do your arithmetic. This is 11 over 2. That's the slope. You're done. Basically, that's it. You're done. What that means is the y values go up 11, okay, when the x values go over 2. Somebody in their iPhone. That's what this means. Remember, the top number is the change in y. The bottom number is the change in x. So when you write the slope is 11 over 2, and by the way, you do not write this as a mixed number. You leave it as 11 over 2, not 5.5 or whatever, okay? This says the y values go up 11 when the x values go over 2. And we can kind of see this. The y value went up 11, okay, went from -4 to 7 was up 11 when the x value moved over 2. That's what that's trying to say. Anyway, for your homework on section 4.4, most of it is going to be concerned with, they're going to give you some points and ask you to plug them into this formula and show the slope. And that's the end of it.
I had a question for you.
Yeah, go
How
ahead.
did you know which one was first and which one was second?
Okay, good question. Very good question. And the answer is, it doesn't matter. Okay, let me show you. Do you guys understand his question? Okay, I arbitrarily said this is going to be the second one. So that's going to be my sub-twosies. And I said this is going to be my first one. Those are going to be my sub-ones. Okay, but the question is, what if I did it backwards? What if I got dyslexic up here? Okay, and I have, here's the point, 3, -4, and 5, 7, 7 same points. But what if I just decided this is going to be my second point, and this is going to be my first point? Just because I want to be weird. All right, well, let's see what happens. So we start with the same formula. M equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So we start. This time, the second y value is -4 minus the first y value is 7. -4 minus 7. On bottom, the second x value is 3 minus the first x value is 5. Okay, you get -11 over -2. But we know that negative divided by a negative reduces to a positive 11 over 2. You get exactly the same answer in the end. It doesn't matter. As long as you're consistent. Once you decide this is going to be my second number, my second ordered pair, then it has to stay the second ordered pair throughout the whole problem. Okay, you can't go, well, this time that'll be second, and that now it'll be second, and you can't get all confused. Once you decide who's first and who's second, you got to live with it. You got to stay with it. Does that answer your question?
Yes, thank you.
Okay. All right, so let's do one more problem for everybody. Is that okay with everybody? Anybody have any clarification?
I just
or
have a
need?
question.
Sure.
Is there any specific reason why you're graphing it?
I'm graphing it only so you can kind of see the line and see that when X went over 2, it also went up 11. So the Y change, the delta Y, the change in Y was 11 when we went over 2, and the delta X was 2. Over 2, up 11, that's what the slope is measuring. No, I only graphed it to give you kind of visual image of what we're looking at. I don't care if you write the graph or not. If you just do this math here, I'm happy.
Okay, thank you.
Okay. Anybody else?
So we are not going to get a question where we have to find the values on the graph before we solve for the slope, right?
Not on this assignment. No,
Okay. Oh,
not on this. We'll get more complicated after you've had more practice. But right now, most of the homework on chapter 4.4 will be, I'm going to throw a couple ordered pairs at you and then say, find the slope, just like I did here. Okay, so let's do the same problem. Find the slope of the line between, I don't know, -7, -1, and 5, -9. So find the slope between those 2 points. So here we go. So the slope is the formula y sub 2 minus y sub 1, x sub 2 minus x sub 1. So the second y is -9 minus -1. Notice it's got a minus minus. Notice, guys, the formula has a minus in it. So you have to always use that minus. So it's minus a -1. So there's where your arithmetic skills come in. Second x, 5, minus first x, okay, -7. 5 minus -7. Now we do arithmetic. -9 plus 1 is -8. Minus minus was plus. -9 plus 1 is -8. 5 minus minus 7 is 5 plus 7, which is 12. Now, that reduces. Remember, we reduce it down. We can reduce that by 4z's, if you wish. Divide top by 4, divide bottom by 4.
Wait a
Okay.
minute. You said -9 and then a -1 makes a -8. Doesn't it make a
No,
-10?
no. It's -9 minus a -1. Look at
I
what the
guess I
formula.
wrote it the other way. Like you said, you could do it. You could put the numbers in any way, but I put -1 minus the -9 and then -7 minus 5.
And that should become 8, and that should become 12. Or -12.
So wouldn't the double negatives over the 9 make the 9 a positive and then make it it would be a +8?
Yeah, but what would your denominator be?
The same thing. It'd be the 2.
It would be -12. No, it wouldn't be a 2, it'd be a -12.
Wait a minute. I don't think we're talking about the same thing. Wait.
Yeah, we are. Let me finish this one off and then I'll do what you're doing. I'll show
Okay.
you. Okay, so I'm pretty sure I haven't made any mistakes yet. So I get 8/12, it reduces to negative 2/3. That would be the slope. Remember, on a fraction, you can slide the negative to top and bottom anywhere you want on the fraction. Now, let's go back and let's reverse it. Okay. So let's reverse it. I'll get out of the way in a minute. I need to write this 5, -9 and -1, -7. So I've reversed the ordered pair. This is going to
Oh,
be
I
my
wrote
first.
-7, -1, not -1.
You can't. Yeah. Okay.
My bad.
Okay. Does anybody need me to do it with the pairs reverse? Okay. By a resounding silence, the answer is no, you don't. Okay. Is it worth my changing it? No, it's not worth my changing it. So in 8 minutes, the quiz will be active on Mom. You do not have to stay logged in. If you want to log out of Zoom, okay, and just go work on Mom, that's fine. I will stay on for about an hour. I will stay in my Zoom session for about an hour if you want to log back in. I can't help you with the problems, but maybe I can clarify if you're stuck or confused. I can kind of guide you a little bit, but I won't do the problems for you. I need to tell you that it's set up that it's possible that 4 people could take the same test and get totally different problems. I've got some random problems in there. Okay, so we all won't get exactly the same problems. Be careful about that. I went and counted. There's 29 problems. Okay, some of them were real simple. I mean, so that's not like 29 minutes. That's 29 problems. One problem might take you like 3 seconds. Okay, I changed the time to 70 minutes. So I'm giving you a little bit of extra time. Okay, because it's our first quiz. You're not quite used to it. I don't want you to panic too much. You'll panic a little, but that's okay. But you must be finished by midnight.
And we can find it at the bottom of the chapter 1 homeworks.
Yeah, it's the one quiz down there. It should light up in about 7 minutes. Okay, I don't know how to spell midnight, but that's okay. So 29 problems. You don't need to show me any work. You just need to put the answers in Mom and move to the next problem. You'll have 2 tries to get it right. After that, you're done. You will have 2 tries to get it right. So the first time you input it, it goes wrong. Well, try it again. Okay.
Sorry,
Yeah, go ahead.
I'm on that last problem. I'm getting it wrong again. I don't know why.
Okay. Hang on. Let me make sure I got everybody going to Mom, and then you and I can do this real quick.
Okay.
Okay. So 29 problems, 70 minutes from whenever you start. It'll set a timer for you, but whatever, finish by midnight. So, I mean, if you want to start at 10 o'clock, if you want to review, and then start at 10, that's up to you. If you want to start now and you're done in 15 minutes, good for you. Go home, go to sleep. Okay. You get 2 tries per problem. After the second try, go on, do another problem. Okay. You're done with that one.
And this is
Okay.
chapter 1 only, correct?
Only chapter 1. That is correct.
Thank you.
Okay.
Is the
Anybody
quiz
else?
gonna pop up?
I'm sorry.
Is the quiz just gonna pop up?
It's supposed to. Yes.
Okay.
Yes, it's supposed to pop up. Okay, let me try this. Okay.
We still have 5 more minutes.
Just for clarification,
Yeah,
we log into Mom and it's going to be under chapter 1, right?
it'll be down at chapter 1 at the very bottom here. It's going to pop up right. I'm going to change this to 7:45, which is after now. And if you're logged in at mom in the chapter 1 at the very bottom, it should now be available to you.
Yeah, it shows up.
It's there now.
Okay, so I just activated it's there. So if you want to leave Zoom and go there, that's cool. Okay, I'm gonna help. Was that Philip that was asking about the other question? Was that who was asking me about doing the slope
Yeah,
problem?
it was
Okay,
me.
that's fine. I just I didn't recognize your voice, so I just wanted to make sure that that was you. Okay, so let me help Philip with
And we
this
can
one.
go too.
You can go. You're free. Yes, free at last. Okay,
Do you want us using
quick.
our notes on the quiz or no?
I would prefer not, but
Okay,
it's
cool.
supposed to be no notes.
Okay,
Okay,
thanks.
but I don't know what's happening. All right, so here we go.
Good
Philip,
night, Professor. Thank you.
good night. So
Thank you,
M
Mr.
is
Foster. Good night.
night, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. But this time I've swapped the order, switched the order of the ordered pairs. So I get,
You go -1, -7 when before it was -7, -1.
oh, you're right. Thank you.
Okay,
that
I
was
was just curious as to how you did or why you did.
No, that was just a screw up on my part. Sorry. Good catch. Okay, so y sub 2 would be -1 minus -9. Y sub 2 minus y sub 1, second y minus first y. This is going to be x
I
sub
think
2.
I wrote the numbers wrong again.
Okay, so you and I
And then
are,
the -1 keep messing me up.
okay, -7 minus 5. Now, if we do this, this will become 8 on top because minus minus is plus. So -1 plus 9 is 8. 7 minus 5 is -12. But that will also reduce to 2 over -3. And we said that in a fraction, you can move the minus sign anywhere you want, top, bottom, or middle. So these are the same answer. So yeah, I screwed you up here by reversing it. I shouldn't have done that. And it sounds like you keep reversing things too. So between the two of us, we've really screwed this thing up. So are we okay?
Yeah, I'm just writing it down now.
Okay.
Do you want me to go to mom?
Well, I just want you to do the quiz. You can stay here and ask me questions. That's fine. Just make sure you get the quiz done before midnight. That's all.
Okay. Appreciate you.
Okay,
But yeah, go ahead. Who's up?
it's me. Sorry. So the
Yeah.
answer is it -2 over 3 or it's 2?
It doesn't matter.
Okay. Oh,
Okay. Traditionally,
uh-huh.
we like the negative in the numerator.
Okay. Oh, okay.
Traditionally, but in the end, it doesn't matter. These three answers,
Okay. Yeah.
those three answers are all the same.
Okay.
Wherever you stick the negative sign, it doesn't matter.
Okay. All right. Thank you.
Yep.
Thank you. Bye. Good night.
Bye-bye. Have a good weekend. Good luck on the quizzy.
Thank you.
Oops. Let me pause
Hi,
this.
thank you, Professor
What?
Foster.
Bye-bye.
Good night. See you next week.
Okay.